Well, computer crashed just as I started the stream, so hence our lack of intro. I was able to get some things going though. Okay, so yeah, no intro because RP computer crashing, but we are here. Hopefully things are working. Oh, here we go. What's my answer? How many steps are required to reach ZZZ? This one. Okay, I'm seeing a 2D coordinate grid here already, or at least instructions to navigate one. Each node, for example, A equals B and C. A, the next left-right intersection example, A, you can go right, choosing the right element. C, then left means choose left of. Okay, I got it. You might not find. If you run out of rough lights, repeat the whole sequence. RL means infinite. Okay, got it. Starting at A. Okay, just keep following the thing. Got it, got it, got it. Const directions or const sources equals data split new line 0 dot split array. There we go. Const. Now what I need to do is essentially make a map of from here to here, from here to okay. Const nodes equals data split new line 1 split each new line dot map line const origin equals line dot split and then const left come on left right equals line dot split around these around those and of course split by the comma and boom we have left right. So return origin left right equals new object for const node of nodes map origin node dot origin equals node dot left node dot right. This is a record of string to string. Congratulations. Okay, so I have that. I just need to essentially while location not ZZZ follow all of these. So but current, what is current? Current is the first top one, right? Starting with AAA. Okay, so current equals nodes 0 dot origin while current not equal the end. So let choice index equals 0, const choice equals left or right equals choices choice index. Hold on. Triple equals R. Hold on, which way is which? Left is 0, right is 1, otherwise 0. There we go. Current equals map current and then left or right index. Great. Choice index goes up by 1 if choice index greater than equal to choices dot length minus 1. Choice index backs to 0. Roll around. Okay, then what am I counting? 6 steps taken. Okay, so let path equals here. Then what we're going to do is say, hey, okay, path got push current. Congratulations, return path length. Let's see if that works. Watch the infinite loop. There's my infinite. Well, hold on. I should move this console to make sure functional before timeout. Okay, yep, infinite loop. Time to jump into debug. We never make it to our destination, unfortunately. There might be additional logic that I have to take, but figure out what's going on here. Okay, so left or right index, going right. So if you look at the path, A, C, G, G, G. Okay, that's not right. So current, map G, map G, you can go to G, you can go to G. Uh-oh, I made a dead end. Okay, let's read these instructions. Start with A and then go right. My path. But going to C. Then left means choose the left of C. Z, not G. Okay, so my choicer is not going the right way. Let's dig into that. Yeah, so 1, so it's also just in line. Okay, yeah, so the first one is take a right. That's correct. Next one is take a right. Well, that didn't work. Choice index. Where is it? One up one. Okay, so something went wrong about that. This will be a right, left, right, left. So let's debug. Yeah, so choice index plus equal to that. Choice index 1. Then we went inside here. Choices dot length minus 1. Hello, 1. Greater than or equal to. It was supposed to be greater than. That's my problem. Okay, terminal should be done. 2 instead of 6. Of course, you may not find. For example, here's a situation. No, they give me 2 examples. Okay, we're going to run this on the real thing. So this example was 2, the real was 6 or whatever. Do I have a console login here? I might need to ditch it. Okay, I don't, thankfully. Stop that. Okay, let's at least add the additional example. While that runs, all I gotta do is watch my saves. Example number 2, which is achievable in 6, it says. So let's make sure that logic is good. Ooh, hit the stack. Let's not add to a path. We don't need that. Steps equals 0. Add to steps. Congratulations. Return. That would have just been, nice to debug for me, but I guess we're not doing that. It looks like both examples have ran. Okay, so I already gotta start thinking about optimizing. The part 2s will not be friendly to me. Need to identify cycles and skip into the future, basically. I think that's the trick. Okay, this is a bit long running. Yikes. Okay, yeah, it's pretty long running. Okay, let me. Well, you don't break the stream. Come on, mouse. Still running. Yikes. Okay, so this is obviously impossible. Let's look at the actual input then. See where explosion is. Yeah, this is definitely supposed to identify cycles. It's also a big map. Ooh, data trim. That's not going to save me, but at least with that, I believe the maps are more efficient. They're more efficient of this. It doesn't really matter there. Steps, just index plus value, then increment. I could do that there, I guess. Sure. Yeah, it still runs those ones there. Okay, let's give this a permanent run. Just to have something going. Next one's going to be optimizing this down to a real map. Or, I'm trying to think. So over one lookup, basically over one lookup. Ooh, I convert the R's and lefts to actual digits. That's gonna send me a little bit of a lookup. Choices dot replace. Oh, not like that before. Replace. Okay, fine. A global. Place. Oh well. The R's with well, left is 0, right is 1. Now that I'm looking at this, actually, yeah, we'll be doing this. This is gonna be a little better. And then the left with 0. We haven't 1. Nope, haven't 1. Okay, and then split that map number. Boom, now it's a bunch of 0s and 1s. And now we take our choice index, and that is literally what we want. I need a new terminal. What number are we on? 8. That's to get rid of our actual solution so we can run this at some point. Okay, great. So at least that's happening. Okay. Think. The efficiency is, I'm going to say it again, cyclic detections. But in the meantime, we can do other things. Maybe. Doesn't feel much better. Maybe it was better. This rollover trick. I could do triple equals actual length, less math, less operator comparisons, sure. I can also always just do modulo, what is that? And just never do that. See how the trick, sure, that's better. I need to do that. Choice index needs to happen. Parent needs to be a thing. Steps is my tracker, I need that. Still over here running, huh? Great. Gotta be cyclic detections. On me for not trying to look up what that performance thing was before I got on stream today. How many steps are required to reach ZZZ? If I go backwards, is that the idea? Let's look at this example. I know I need to get to Z, which means I know I need to get to B. Huh. Is going, well, backwards, I'll still have to count until I get back to the whatever origin that is. Okay, how is this one 6? Left, left, right. So B, A, B, A, B. The heck? How is that 6? Eventually I took a right. Ah, okay. Basically, if I ever end up in the same place twice, I should be able to fast forward by the number. I have to compare the last time I was there. I think it was 2 examples here. Let's say I gotta write this one out explicitly. This thing finished running? No, I don't think. I have made it more efficient now, so let's give it a full run. A scratch run. See if we get lucky there. So yeah, I gotta step this out. So we have 0 equals AAA. 1 equals, hold on, AAA, L, 0, 0, L, BBB, 1L AAA 2R BBB 1L AAA. I have to write this out, unfortunately. 2L BBB. Nope, I did it wrong. 0L, 1L, and 2R. ZZZ. Okay, so there is a way to fast forward this. That's what I gotta find. So once I go from A to B, congratulations, I made it there. Once I make it back to A, I should be able to realize, hey, last time I was here, I was at 2. Well, no, hold on. Okay, I need to determine. So A 0L, B 1L, A 2R, B 0L, A 1L, B 2R. Here's the thing. I can't think of an easy way to fast forward it because they were never at the same point of the choices array. If they ever were at the same point, it would be a true cycle and it would be infinite. So I'm glad they're not. There's something here. So let's get back to A. It's been 2. How can I fast forward? Maybe our indexes are wrong. Fast forwarding based on instructions. Maybe I build a shortcut maps. So I can say AAAL equals BB. I create loops basically. So AAAL is AAA. Basically, I would create the own maps basically to it doubles the amount of those. Which how many do I have? Yeah, it's not even 1,000. Huh. Not seeing it. But that's running, right? What the heck's going on here? Did it just finish? Didn't have the console on? Oh, okay. Well, I'm the idiot now. Hold on, that thing's not on watch mode, right? That's not what happened. Nope. Okay. So I did have an answer. It's just gonna only be for part 1. So I'm gonna keep that open now to save me the few minutes I just burnt in the trash. What's the fast forward? Maybe the backwards idea wasn't completely off. Let's look at my actual input. See if I can recognize a pattern in steps. Yeah, lots of left, right, left, rights. No pattern recognizable. Maybe data structure is the key. May have effectively just built a graph here. Yeah, it's basically a graph. You have to go through all of them. That's what's taking so long. It's literally traversal. So they only ask for how many steps it takes. Is there a shortcut to getting that information? Time to read the rest of the instructions. Wait, I assume A is first. A is first, right? No, 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 no. I'm an idiot. Great, 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 great. Nodes. Find node. Node origin. No, node is always AAA. Well, I bet this is gonna go real fast now. Why you console? No. It might not go fast, but yep, that's on me. Idiot. Okay. Significantly more steps. Yes, not optimized. Start at every node that ends with A until they all simultaneously end up. Okay, great. You end up entirely that end in Z. Oh, end in A and end in Z. Okay. Wait, what? We read. Start every node and fall all same time until they all simultaneously end up at nodes. Okay, so it's multi-simulation. Got it. Copy this. Basically, I've created a bunch of copies of this world. Give me my example. We get one example. What's up with the x's? Huh. I don't remember x's being a part of the equation. What did the x's do? Okay, that cool is a cool fact. I love factoids. If only some, you act like any other node, continue as normal. Okay, great. So let's create const layers. So I'm going to call them. And these are all the ones that start with A. So that's nodes.filter and origin ends with A. Dot map in A example. Coming on that. We got current and origin steps 0. Oh, after 6 steps. That doesn't need a track. Awesome. The current is always going to be the same. So it's going to be while players dot every. While not players every. Yes, it is. It is. Well, it's not midnight. It's 11:22. I'm in Central Time. So while they're all not current ends with Z, so while you're all not on Z's, we keep playing. Keep all these two indexing around, having a good old day. But now we say const p of players p dot current equals. Oh, great, and I get to change my. Yeah, let's do this logic here. Save the operations. Choice equals this. Great, now y'all get to say math.get current. Y'all take the same left-right choice. P.current. Congratulations. Goodbye. I have solved 2 right there. Let's see if it runs. Not working. Expecting. Okay, 78. Ah, true. Okay, that's supposed to be 6. Boom. Okay, 0, not 6. So this isn't running. While every player doesn't ends with Z. Some not ends with Z. I've obviously flipped this logic around wrong. Hold on. Hold on. What's the rule? Yeah, they're all starting at A. What are players? They should all just be the A's. Come on, scroll. Yeah, 1 A and 2 A. So this should be truthy. While some character doesn't end in Z, play the game. Okay, I gotta jump in the debugger on this one. I've obviously written this expression wrong. Did I copy the thing wrong? Nope, that's solved too. Okay. Great. Players command bug console. Yeah, this is true. Okay, you're going inside. Great. Okay, so you do your thing. Oh, steps never increment. Steps never increment. Fixed it. Where's terminal? Oh, big console log. Not do that. Thank you. Rerun the big one. spend some time thinking about efficiencies. About that. Okay, now this is the one that probably does need the get smarter in some way. But this one I see actually maybe being possible, since different paths could overlap the same thing. I am curious how much time I burned on not realizing A wasn't the first one. Ah, yeah, that wasn't very good. Interesting. Hmm. Just gotta be jump ahead here. Wait a minute. Um, I should. So whenever one does hit a point, it should take the same amount of time to get back to that point, or else it wouldn't be able to get back to that point at all. So, for example, if the first one gets there every 10, and the other one gets there every 5, and they start off weird, eventually they'll line up on 10 and 5, and what's that called? It's one of the math things to find the most common thing between them. Then zoom ahead. Uh, do, 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 do. So I need to, instead of running them all at once, run them one at a time. Figure out how many steps it takes to get to the thing. Steps taken. I have no confidence in that. Let's save some CPU. For const node of nodes. If node origin ends with A, continue. You are not the chosen one. But if you do, then run a simulation, basically. Node origin, then while not current ends with Z, you haven't made it. Oh, also this gets reset to the beginning. Basically, this entire thing is embedded in this loop. Current equals map.get current, and then it's this logic here up here. Yeah, that's good. Increase by 1, bring that variable up. Then once you do make it, taken.push. Congratulations, you made it. And then I can't run this. I can't figure this out. At this point, I need to look at the actual output to try to recognize the pattern. Cannot see that in my head. Did it break? Okay, we made it. Steps taken 2 and 3. 2 times 3 is 6, right? I'm trying to think. I know how to spell the word calculator, don't worry about it. It's one of these math terms. Just give me. So it's 2 and 3. Nope. What's the other one? The LCM. Come on, 2 and 3. 6. Okay. JS. Yeah, I do not do math. Off the brain. Least common multiple range. I'm just gonna copy a snippet. Do not give me a 50 line thing. Least common multiple min max. Wait, LCM. Is this what I want? Ah, LCM. Smallest common multiple. Ooh, is this okay? This seems good. I'll take it. Okay, then I call this on steps taken. It should spit out a 6. Okay, you're auto running. I mean, hey, you're auto running. That means that. Stop. Stop that. Hmm. Okay. I anticipated this to be fast and work. It's working. It's not any faster, though. I thought math was the answer. Am I doing it wrong? Is this doing it wrong? Huh. Only A's. Yeah, we're not making that start from weird again mistake. You're not both gonna run. So that's passing this example. Yeah, it's at least jump into here. Stumped again now. I mean, yeah, we jump in there. I guess we didn't actually jump in. Still running. Still running. Hmm. Hmm. Let me look at the inputs again. They're all 3 digits. Does that have any use for me? I mean, it means I don't have to use ends with or beginnings with. That's more efficient. Origin, um, 0. Well, 0, not equal A. So yeah, that's probably better call. Current 0, 1, 2, not equal Z. Keep running with your life. So sure, it's not really gonna get it going too much faster. Let's turn that watch back on. Oh great, infinity. I broke it. Origin 0, 1, 2. Wait, is this? It's ends with. Yeah, it ends with on both sides. I got that wrong. Sure. That's cool. Mm. Go ahead and restart this. Feel the efficiency is worth it. Okay, what's happening here? Anything happening here better? No. No, no, no. Nothing's better there. What if my assumption of the cycles was wrong? But it's only right for the example, which is annoying. Hmm. Oh, am I doing the modulo or the math? So maybe I was wrong about efficiency. Well, current's not. This is math. Maybe we don't like math. Maybe this math is bad math. Cost car of, or first const I of choices. Then we'll just say, hey, you're gonna do this, this, and then I'll embed the condition here. Current 2 equals z break, just to keep it from going crazy. And we'll just say, take the I right here. Not enough for me to restart the main process, I don't think. Back to main, still running. How many do I have? Let's have a quick peek at that. Okay, so 737 99. Wait, it's done? What the heck's going on here? Oh, is this math I grabbed very bad? It is. Oh my goodness. Just an online LCM calculator. Yep. It's all about the common beginner mistakes today, it seems. Just shove them in the thing. Expected one number. Do I go for the least? What do I put? It gave me one number before. What am I looking for? How many steps does it take for you only on nodes at end of Z? The largest, or do I take the multiple of these? Just steps working out. Okay, I don't understand the math. Biggest number. Not the right answer. Okay. Well, this thing's not even calculating it, and I don't even understand it. We'll see. Smallest number that of multiple though. Multiple. Ah, three more number. There we go. Come on. Oh, it's recursive. Oh great, math. Okay, I'll steal these. Okay. I can do Python. Const LCM equals. Congratulations. Turn. Oh, reduce. Okay. Nums dot reduce. Wait a minute. If it's just that, then I already have it. I can use my existing one and reduce on steps taken. Reduce AP. What's it? Initial. Well, initials, whatever the first value is. Smallest commons A B. Why? Why you know? Why you know happy? Oh, it's supposed to be an array. Whatever. That seems right. Nope. Okay, gotta do this better math instead. Okay, let's do. Come on, keyboard, be in the right place. LCM equals a number, b number, a times b divided by b. That's whole division 2, which is a number, b number, turn. Okay, so while b a b equals b a modulo b, return a. Sure, good enough. B, C, D, A, B. Good enough. Okay, big number. Probably wrong because I didn't do the whole interested vision, but we will find out. It is right. Okay. How much did I lose on those beginner mistakes? Huh, not bad. So, that was a good one. Bit tough there on me. So I happens when you don't know what you're copying. You just copy it, and it's wrong. Yeah, goodbye to that code there. Yeah, just get rid of these consoles and stuff. We'll commit, and we'll come back and clean it up. Stop running. Stop running. Yeah, that was a pretty good one. Just didn't check my basics. Today's day 7. Day 8. There we go. With that, I will see you on the other side of the break. welcome on back. Is optimize and explaining. Nope, don't. And explaining. Yeah, this is a fun one, and you're definitely going to be seeing me visualize this tomorrow or the next night. That's when I have the most free time, the weekend nights. But yeah, so let's hold off excitement off just for our optimization. So I'm trying to think, because the base of these are identical, the setup. It's the running and... Oh, no. I can use part 2 for part 1. It's just the criteria for is start node and is end node differs. Yeah, because watch, I'm going to take this and shove it into solve 1, and all I got to change is the check conditions. Move the 2, triple it up. Bad. Well, my hand's on the wrong key there. There we go, and boom, that will now work for numeral 1. Bingo bango. See? So, boom, I've optimized it. Good job, we all get to go home early. Nah. Okay, so still make that an option. Don't need that in anymore. I thought I was gonna use it for... I use it for the console lock, that's what I used it for. Okay, so let's make these in a bunch of little tiny functions. Const. Yeah, we'll make this into a little function here, which is going to be basically this one-liner here. Yep, right and left, 0 and that. Yeah, that's perfectly fine to me. We don't actually need that until later, so calculations, we just got demoted. And the next one's going to be generate node map. Generate, well, we'll call it a graph. That's effectively what it is. It's this logic here. Well, so yeah, these are the nodes, and this is technically all your edges in the world, so congratulations. Yeah, these are the edges. Split. There have been worse. Turn, nodes, edges, not edges, edges. There we go. I could split these even further, but this is good enough to me. Const nodes edges equals generate graph with the data. I could pass lines here actually. There we go. So then we'll just do the splitting and stuff on this part. Split 1. Beautiful. I like that there instead. Now here, there's an optimization. Since the LCM is calculated reduce-wise, it means I just need 1 at a time. So we need this here. Let what is this? Min steps? Total steps? There you go. Starts off as null, and then as we go along, we start going happy with it. So if total steps equals null, steps equals steps. Else total steps equals LCM. Ooh, A, B. A is the one I've already had, so it's total steps. B is the newcomer, so that's steps. Now get to return steps. I don't know how many were in that array, but we just Saved all that. Beautifully running still. Well, that's for part one. It's a good enough test. Could show the filter on there, but it's already there. So steps current. While current's there. Yeah, we're not gonna call these origins. That's label. Ah, it's not the refactor I wanted. Okay, let's do this. There we go. I like that. Yeah, I could have actually made this an actual graph object references and stuff, but I might do that after this. I have choices. Now this, I don't know if I like. Efficiency one way or the other, but I don't like the way this one turned out. Saves me a variable, but it adds a loop. I have to double check conditional. I don't like it, so we're going back the other way. There we go, choice index 0, so that's choices, choice index plus plus modulo. Choices length, yep, I like that better. Drop the loops. Bingo. Yeah, I'm making sure this thing's running it, so it didn't look like it. More variables, but I like it better. Down there. Good enough. Ooh, total steps is always getting reassigned here. It's the first one that's being the weirdo. Can I easily... Well, I don't know about the math, so we're just gonna hit 0. No. Math happy with 1? No. Okay, math happy with number max safe integer? No. Okay, why is it not happy though? Maybe that will actually be informative. Cannot access before initialization. Oh, no. Oh, yeah, because const. That's a bit on me. Don't know how that was working before. Nobody asked. Oh, runtime condition, yeah. I love runtime conditions. Or race conditions. Tomato, tomato. Okay, now can I use math experiments? No, okay. There we go, yeah, because I speak this as an expert in the field, obviously. LCM of anything, and 1 is the anything, not the 1. Total expert. Okay, all that is our end and our is end is beginning, which is going to be a little bit more expensive than these hard codes. But it's going to be worth it to me. Seems so isolated. We'll do that. And we'll do that. Steps. Now this actually, I did a for loop and all this, but it's going to be nodes reduce. Let's go full functional craziness. So that's return nodes dot reduce total steps. Well, I think in this case I would want to do the filter then. So let's hit it with the filter first. Go full functional. Yep, if you're not A, then you suck. Initial total steps is 1. Gotta handle that. Well, actually, yeah, you need to handle the initial because it's not the initial value. If you do stuff with it. All this lives in here. Steps, current. Then I return LCM total steps and steps. Does that work? Oh no. Oh no. Why is it not work? Total steps, node. Current is not Z. Oh, we want node label is AAA. There we go. Okay. Yeah, liking this so far. Still need these double conditionals for determining start and end. Edges, nodes. Yeah, okay, I'm liking this. Let's polish it up now. Oh yeah, this. Might as well while we're here. Okay, it's time to make this generalized. So, congratulations, solved one splitting time, and you are now solved. So let's do our. I might as well provide regexes. It feels cool. Regex and feels cool. So this will be start regex test. Not the most efficient regex in a test call, but I don't know. I like it. And regex test. So while you're not at the end, you're gonna keep going. Cool, I like that. Now we call return solve data. Then we have start regex, which is AAA, end regex, which is ZZZ. But come on, loving it. And part 2 is the same, just a single character. Look, too many curlies going. So it's anything A, and well, technically it ends with A, so it's dollars, well, A $sign and Z dollar dollar dollar. Runs like a charm. Okay, so I like this. I'm a fan of this, big fan of this. I can see another way of doing it though. We're gonna go ahead and call that an optimize. But we'll go for the other one and then we'll benchmark the two, see which is actually better. It's been a while since I did an optimize. Oh, that's just bad scrolling. Boop, ba-da. There we go. Optimized away. The heck is... Yeah, guess code changing on me. Scary. But yeah, let's go into the object-oriented way of doing this, which I don't know if I'm going to like it. I'm just going to give it a throw. So instead of left right being names and label being label, okay, label will still be label, but left and right will now be references to the actual nodes. So node left. So we have edges. We're gonna want a graph cost. Well, yeah, we're gonna want a graph to get to any node. Equals new map or const node of nodes. And then it'll be graph.set node dot label, and this will be node. Well, node label's already there. Left null, right null, and when I create new ones, I'll have to hook it up because of the looping factor here. Node labels. These aren't full nodes anymore in my mind. Node info. For info of node info. There we go. So this is the actual node. Node, congratulations. if graph that has, where is it? Info dot left node dot left equals graph dot get left. No, we'll just do this or null. Boom. Let's do the initializers. And it's not node, it's info. And yeah, left, right. This one's right. There we go. So this one, if it's already in there, it adds it. But if it's already referenced by others, I need to go and add those too. How do I do that linking? So like say, well, how do I think of a case in my mind to actually explain it easier? Ooh, mine is racing though. I wasn't even thinking, I was just losing train of thought there. Okay, we need the example. So A, B, 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 C, C, C. So boom. A goes into the world. No, no, because neither of them are in here. Okay, congratulations. And let's say BBB points to AAA, CCC, and CCC points to BBB, AAA. It's a big loop. It's a triangle. Illuminati, congratulations. Which means we have BBB getting added. Ooh, his left is AAA, so he gets AAA, but then null. And then null. Well, space is ugly, gross. But that means AAA is still pointing to null. Null. Which is no longer factual. AAA is left null, should point to BBB. Now that's going to happen when this happens. So if I have a node left, I have to go to that node left and update it. So if node left, graph.get node.left. Again, if it's left, then it's dot left. Wait, what's the other type of this? Left equals node. Got it. And the same for the right. So you just need to slow down, get our test case out here. That should make a fully interconnected graph that can be looked at by O of 1 and followed to your heart's content. Goodbye, edges. I said goodbye, edges. Goodbye, node info. Well, you can one-line that, or inline it, rather. It's a bit gross being inlined, but it's right. Let's at least make this somewhat readable. I'll need to look at this initially to make sure this is good. Visually, I feel. Graph. Congratulations, you had a graph. And you're going to say, ooh, we want to go through all the keys. Well, all the entries, actually, and filter by the keys that are starting. So, ooh, this is a map. So it's graph.entries. Filter, parentheses, label, node. So label is a starter. Good job. Reduce total steps. Underscore, we don't care about who you are, we care about where you are. So yeah, current is node. Node. Awesome. Goodbye, current. Oh, wait a minute. I don't have my label, though. Yeah, maybe I should add that information. It's going to be a duplicate of information, but just for simplicity, we're going to go there. Congratulations, you have a label. Okay, destructure this one info. I'm gonna destructure this from info. You don't need that variable around anyway, and then at this point, it's like why we've been doing that parsing. Just do it up here. Up there, I said. Const line of lines. Yeah, kind of bleeding all together here, but it's alright. Label left, right. Boom. So there's your parsing, your node generation. Everyone's happy again. And now we have nodes. Node.label current. Well, it's node actually. Node equals node dot, and then whichever side you want to go. So I guess I'm gonna have to use thing to turn the ones and zeros back into properties. So if it's a 1, then it's a right, 0, then it's a left. And commit your steps, be happy, run. Great. Cannot read null regarding a label. At some point we go off the filter. This is where I need to actually inspect the graph. Because I do not trust it. Okay, let's see. For example, A goes to... It's already broken. It's already broke. So A is not supposed to go to A. A's supposed to go to B. Nodes are any of these? Nothing's working. Okay, well, at least I know it's not some edge thingy. Suppose we gotta go through this. Scored. Go, okay. So let's at least jump up to here, see what we got. Okay, our node is A. We got no friends. We are friendless. But we know we're pointing to B and C. Now this node doesn't know that. It's about to lose that information. That's okay, because B and C... B is gonna know it needs to connect to A, and it's about to find out. No, it's not. So graph dot get left should have done the thing. Left is what? Graph. Okay, maybe it's right. Right is... Heck, I'm B. Do I not have connections? Okay, connections to D and E. C, Z, G, D, self, E. I'm also not considering the self links, which is incomplete of me. Okay, I'm seeing the problem. There is no backlinking happening here. They never link back to each other directly. It's always forward. Why is this one though? A points to B, B points to A. Okay, so it's just incomplete. I just assumed it would be ordered in a way, and it's not. At some point, they're gonna be all nolly. We're not gonna like it, so we're gonna have to go back through it a second time and replace our strings with nulls. I don't like that. If else, so yeah, this is literally useless. I mean, it's not literally useless, but it's not worth the effort doing it that way. We're gonna have to go through the graph twice. Let's just go through the graph twice. Const label. Well, we don't need the label. We just need the node of graph dot values. There we go. Let's see if node dot left. It's just gonna be a string check. Nope, where'd that go? Great, if you're a string node left equals graph.get node left. Congratulations, just got upgraded. Do the same thing with right, and eventually it'll all be happily linked together. We'll see that right now. Take a Bill moment there. I'm not happy, but there we go. A, B, D. Which also does link to the circular one, which is not my problem. I'm never going to console log this. Let's see if that's functional, though. It is functional. So yeah, double loop to generate the graph. I did reduce mapping for parsing, but at this point I could reduce over lines, generate the map itself. I'm going to go through it a second time. Let's go ahead and do that, why not? Reduce, map, line. Too many symbols. Boop, boop. Turn graph. New map. There we go. And we still have to do our loop, so not like we're getting out of it. What did I do here wrong? I did something wrong. Did I not type you correctly? Oh, return, oops. There you go. Okay, that's good. This has literally no purpose since, I mean, maybe this is useful. Statistically speaking, we're gonna have to go through them all over again, so let's just say goodbye. Label left, right. At this point, we're just making the associations and the objects, which is fine. Good enough with me. Then linking them all together, good enough with me. This changes. Okay, we have. Okay, drop that. We don't need the entries anymore because we specifically have values of labels on them. We increased our memory footprint to not do that anymore. So values, which we now have a node, which we can rip the label out of. Well, we just have a node to live our life with, which has a label. Now this is what's changed. Left, right are now these things, which I'm trying to think the best way to do it. Still key as far as JavaScript's concerned. The 0 and the 1 were also that. They're just now we have to do calculations to flip them around. If I just LR up here, it would use the original characters. It's a micro optimization at this point. Don't think it would have a lot of impact on what's going on. But I'm not about to leave anything on the table, so let's go for it. So yeah, left and right. Let's just keep them as is. Let's touch nothing. Let's just do the split. And leave it as so. So now we have an array of the left of the L's and R's. Now I just gotta refactor on this thing here. L left, R right. Cannot rename element. Well, you're sad. LR. Boom, straight to the characters. Should still work. I broke it. I missed some point. Dot label. So I still got the label. L left, L right. Choices wrong. Choices must be wrong. Let's check out choices. Ooh, they're capitals, aren't they? Yeah, they are. Two lowercase. Not locale. Lowercase. We're not fancy. Okay. This is the best this solution is going to get, I believe, in my mind. At least compared to. Thinking away squishing this into one line, but it's, yeah, dangerous thoughts. Very dangerous thoughts for me. Most dangerous thoughts. Oh, look what I've done. For line. Absolute misuse of a for loop. Oh, no, it's actually perfect use of the for loop. It's what it was designed for. Choice and let's go further. Yes, this is an improvement. I'm trying to think. Right? No? Oh no. The only reason steps is outside is because it needs to exist outside of scope. Mm, this is disgusting. Absolute horrific. Why couldn't we do this before? Because I was not creative enough. That's the only answer. Okay, so for the purposes of benchmarking, we're not about to do that. For the purpose of crazy commits, it's tempting. For benchmarking, we're going to keep it equivalent as possible. Now it's benching time. Well, trying to. Gotta go grab my gist. Yeah, this is V1, V2. And we're gonna leave that there. Back to that. Bench.js. Where are my gist? There it is. My friend. There we go. The magical do bench. We're gonna give it. We'll give it one's any functional difference. No, we'll give it 2. No, we'll do both. We'll just make the thing customized. We'll do all the things basically. Yeah, so let's break it. I didn't mean to drag that. Let's start clicking stuff over. Solve, parse, math. We need all these things. Let's remove all the types from it. Colon space, colon space. Yep, goodbye, all of them. Yep, look at the rest of these. Colon space. Guess. There we go. Look, it's JavaScript. Okay, now let's call one of these. Do bench. Solve P. I think this is also generate graph. P. Parse choices. P. Yeah, just domain them off. Okay, so our function. Hold on. Do bench. What's this do again? Takes our test function. Let's grab both test cases just to give it something to do with its life. Wrong one. function number 1. And this is with, yeah, gotta make sure the regexes are in there. Let's go add the second one, and we'll add those regexes. There we go. Let's grab the regexes. So for 1, full strings. Bango, bango. 2, get the little one. This is another funk call. This one's not like, get out of here. Too many quotes. There it is. Grab the other regex. Beautiful. Now we need our data. Const data equals require fs. Where are my quotes at? There it is. Copy rest of that. Read file sync. Boom, we have the data. Finally, it is func data. One with old regex, one with new regex. Beautiful. Now we pass this our one function of solve OOP, and things should be off to the races. Solve func, I guess we'll call that solve functional. And this is the part where I gotta go time traveling. How do I preview? Not discard. Okay, I'll copy the whole file. Not shove it here because I need this one. Shove it here. Discard changes. 2308TS. Jump back in there. Recopy all of this. But now it's func. Where is it? There's my bench. And time to say goodbye to the power of TypeScript. Well, I need that line apparently. There we go. Those are gone now. All that I believe remains is the execution. Let's hit this up. Begin the benchmark. Okay, these are not a lot of operations per second. OOP 83 ops a second. Ooh, okay. Object oriented, slightly faster. Tear it up again. Sanity, caching, all those other good reasons. Variance of 5. Okay, functionals, very consistent. He's got the fluctuation going on. Now I'm seeing this maybe as a result of the ordering of OP and functional, so we'll swappy swap. Okay, yeah, I'm liking what I see. Just flood the computer. Give it lots of things to do. I don't know if that actually works with the same name. But yeah, object oriented, not once has it faltered enough to be compared to functional, and yeah. So yeah, I am happy with my object oriented approach. Now let's go all the way with super OOP. solve crazy object oriented. And that's just gonna be me taking the object oriented one. Where'd it go? Here it is. Sandboxing that. It's not too crazy, it's just double return, love it. There we go. It's just squishing that to all squish can be. It should be functionally identical. Yeah, functional identical is what I'm looking for. Functionally identical, yeah. Another one for good measure. Which means I will be using the crazy one. It's just so crazy. Okay, let's bring all of the code back to our file. Not 7, 8. And not forget to bring crazy along. This is awfully readable though. But this looks cool. Readable versus crazy. Ah, this is very readable, and we're not getting. Oh, what bench? What the heck happened? Benchmark just got real interesting results there. Nothing fell. I must have been doing something with the computer at the time. Different things bulking down the CPU. Okay, so yeah, functionally a little better actually, but looking at it equally. Okay, the only difference is actually these 4 lines here. I don't know why I'm copying the entire world. Oh, because format decided to throw some stuff around. Weird. And it's not even all those lines, it's the 3 middle ones. Okay, so it does scope choice index, which I do like. Does belong in there. The conditional is the same. That's no impact. The node traversal is the same, and it saves a thing by putting choice into by steps incrementing into here. I can put that at the end. I'll be happy because this is all the stuff regarding the loop. This is our track variable. Yeah, I'm happy with this. It doesn't look too godly unreadable. Not seeing a better way to do that. Ooh, is there... I'm trying to think of an operator. No, there's no crazy operator that's like type assignment craziness. Okay, I'm liking it. And I am sold. Still works. Let us commit away. So this is another optimize unit. 2 optimizers for the price of 1. Which, so yeah, this is effectively just transformed it to object-oriented and... yeah, made it an actual relational graph. Then we squished that while loop into for loop. Yeah, that is problem of the day done. Now, for the visualization that is definitely on the queue for this one, it's going to be somewhat straightforward. So well, it's going to be not one computer visualization. So you got A, which points to B, ironically, both left and right point to B. Then B, which goes to Z. No, that's there we go. So A's left goes to B. A's right goes to B. B's left goes to A. I'm not really representing this too well. B's right goes to Z. Z goes to Z. And then Z goes to Z. Yeah, again, not really representing this too well. But yeah, at the very minimum, I'll figure out a better way to present this. And it will, because these are directed, not bidirectional, just single directional graphs. Yeah, the thing will basically be highlighting which line we're traversing. So there'll be a thing highlighting this as a different color. Then we'll highlight this. It'll be like, oh yeah, you're on A. And you're going left. Now you're on B. And you're going left. Now you're back on A. And you're going right. And blah, 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 blah. Eventually, you're on B. You're going right. So yeah, that'll be that visualization for the part 1 of the equation. The part 2, however, to visually represent the LCM, it's gonna require me to fully understand. I know that it works because I've seen the jump ahead technique used. Don't have the full integral understanding it in my head, which I would need to properly visualize. And all of this, yeah, so it's just building the graph, a good chunk of the work. Animating the traversal, another petty chunk of work. I'm trying to think the way I'm doing it now. It is node by node and then calculating. What am I calculating? Cycle. The steps to get to that node, and then basically when they line up. The most common example of this is the fast and the slow cyclic detection with linked list. But there's a difference of 1, so it's not really LCM, it's just it'll eventually line up. But yeah, definitely looking forward to, at a very minimum, graphing this, because as much as 700 nodes is, you can fit 700 nodes on a screen. You know, that's not that much. Now, the lines, it's going to look like spaghetti, but visualizations generally excel on these sample inputs anyway, at least for clarity. Doing it on the problem input is more of a chaos unless you're an expert at it or find the craft. But yeah, with that, that is today's done. Be back same time tomorrow. We may do an actual visualization. Toodaloo.